The topic for week 3 is partial derivatives. And the menu for week 3 is going to start out with functions of several variables. So remember, our goal is we want to be able to take the partial derivatives of the Black-Scholes pricing formula. The Black-Scholes pricing formula is a function of many variables. So we'll start off just defining what we mean by a function of many variables. Then in section 2, I'll talk about higher order partial derivatives. So remember, a higher derivative was just when I took the derivative of a derivative. When I have a function of more than one variable, I could take the derivative of that function with respect to y. That will give me a new function. And then I could take the derivative of that function with respect to x. So now it's actually possible to mix the partial derivatives. So we have to talk a little bit about how we're going to deal with that possibility. In section 3, I'll give a concrete example just using a function of two variables. Section 4, I'll talk about an extension of the chain rule for functions of several variables. And in section 5, I'll talk about implicit functions. So an implicit function is a function that I can't write as y equals f of x. It's something a little bit more general. So a circle, for instance, would be an implicit function, because when I write down its equation, it has to be x squared plus y squared equals r squared. In the second half of this week's topics, I'll start talking about the Greeks. And so the Greeks, recall, are the partial derivatives of the Black-Scholes pricing formula. And I'll start off just by introducing what the Greeks are and also a notion called put-call parity. And then I'll talk about the 5 Greeks. So we have delta, which is the derivative with respect to the asset price, gamma, which is the second derivative with respect to the asset price, then rho, vega, and theta. And so these will actually be just complicated calculations, but it'll be nice just to go through them once, I think, in course with slides, so you can see how they're done. There's some very nice tricks you can use to simplify the calculations that, if you just try and do this on your own the first time, you might not catch.